Okay, so moving on to linear law, which is looking at the same thing as we've been doing, which is with differential equations, which is where we create models for different situations, but it's looking at it from a different angle, looking at it from the perspective of the data that we might collect. Okay, so the first thing we need to know is how to rearrange a logarithmic equation, which we know really well how to do. We know you've got to collect all the log terms to one side, so I'm going to move this log term to the other side. So that gives me log to the base 2 of y plus 3 log to the base 2 of x equals 1. And then we want to squash those into a single log, but we can't squash them into a single log with that 3 at the front there. So what we do with that 3 is we lift it up into the power there, and then we can squash it into a single log. So that gives us log to the base 2 of yx cubed equals 1. And then opposite of log to the base 2 is 2 to the power of 2 to the power of both sides. And so that gives us yx cubed equals 2 to the power of 1 is 2, y equals 2 over x cubed. So this equation and this equation are kind of the same equation as each other. You might argue they're not exactly the same as each other, because for this equation, x could be negative. And if x was negative, y would be negative. And this equation, x and y cannot be negative. And so they're not entirely the same as each other. But if you restrict the domain of this to x is greater than 0, then they are exactly the same as each other.
Or if you make a modulus of
or if you replace those with moduluses, yeah. Okay. Yeah. And the problem with that is if you replace that with modulus, you won't get negative values of y, because they'll just end up as being positive values of y, but you won't know whether they're negative or positive when you put in a value of x. So it works sort of like, 50% of the way there, but it doesn't get 100% of the way. It's asking us to rewrite this equation. So in this case, there aren't any log terms to collect, so I'm just going to get rid of the log first of all. So I've got log of n equals 2 plus a 10th t, and I'm going to do 10 to the power. Now I can't do 10 to the power on this side because I've got two terms, so I'll have to bracket them first and then do 10 to the power. So that's going to give me n equals 10 to the power 2 plus 1 over 10 t. Now that looks a bit messy, so what I can do is rewrite it as 10 to the power 2 times 10 to the power 1 over 10 t. N equals, which is just n equals 100 times 10 to the power of a 10th t. Okay, so there's my question, and actually that is an exponential growth equation. That is an exponential growth equation. So we recognize that that's going to be an exponential growth equation. It's going to start from 100 and it's going to grow exponentially like that. So we should recognize that as being an exponential growth equation. Now we can rewrite this a bit more if we want. What we could do is we could take this 1/10 and just push it into the brackets. It would still be the same equation. And then 10 to the power 10th, we can just stick that into the calculator. So 10 to the power of a 10th, I've just typed in 0.1. Oh, my camera's off. I didn't know that. I pressed the button, it must have just not clicked. I never leave my camera off, so I accept when you're doing the test. So if that happens, just tell me your camera's off. And so there's my answer, and it gives me 1.25, let's call it 1.259. So 100, n equals 100, brackets 1.259 to the power t. Okay, which is also our exponential growth equation. It's going to be the same. It's going to look exactly the same as that. It just, I suppose this is more like, that's more like an exponential growth and decay equation. This is more like a compound interest equation. It's the same thing. It's a 26% year-on-year increase, if you like. Yeah, 26% compounded increase in whatever n is. N might be a population. It sounds like a population, n. Okay, they asked us, oh, no, they wanted it in the form of e to the power. Okay, we didn't give it in the form e to the power. We could have done it when it was here. But seeing as I've already got to here, I want to rewrite this, that 1.259 as e to the power something. So e to the power of ln of 1.259 is still going to be 1.259 t. And then I'm just going to type in that ln of 1.259. So ln of 1.259 gives me 0.23. So e to the 0.23 t 100 n equals. So we can change it. We can change the base to whatever base we want. Here the base was, if I just push that back out again, here the base was 10. Here the base was, well, just what it turned out to be, 1.259. And here the base was E. They're the three main bases that we would like. E, 10, and then whatever the base turns out to be. Okay, what's the problem here? I'm going to ask you to do the same thing as we did on the last one. Collect the log terms together, squash them into a single log, and then rewrite it exponentially. But what's the issue? Can you foresee that we're going to have a bit of a problem here, Aaron? What's going to cause the problem?
Yeah, there's a log base 4 next to the P and a log base 2 next to the T.
Okay, that's going to cause a problem. You're right. Is there a way we can change this one to make it the same base as the other one?
Yeah, because log to the base 2 is the same as... No.
So if you've got log to the base b of a, and you decide, oh, I know, I'm going to square them both, it'll be the same thing. It's exactly the same. If you square them both, it's going to be exactly the same. If you say, no, I'm not going to square them both, I'm going to cube them both. Cube. It'll be the same.
So we'd square the t and the log to the base 2.
If you decide to recip them both, it'll be the same. If you decide to times them both by 2, it won't be the same anymore. Now, no, you've destroyed it. Why did you do that? I see that a lot. When my brothers were little, right? They're a lot younger than me. They're like 10 years younger than me. And so you know what little kids are like? They're always asking you to do stuff. And do a drawing of a car for me. So I draw a really nice drawing of a car. I draw this car. I mean, I take my time over it. I draw a really nice drawing of a car, and it'd be like a really nice looking car. And then I'd be drawing it and stuff, and then they go, okay, it's looking really nice, and there'd be a driver in there and all this stuff. And then they go, what is that? What is that? And then I'd go, oh, okay, you don't know what this is. Okay, well, you know, you should look out for it, because these do happen a lot, yeah. And then they go, well, what is it? And I'd go, and then I'd do this, and then I go, bang, and then they would explode the car, and you'd get like lines all over the car, and I'd scribble all over it, and then they'd start crying their little eyes out because I just ruined the drawing that I'd drawn for them, and they'd start crying their little eyes out. And I used to find it so much fun that they cried over stuff like that. I wasn't a nice older brother, I don't think. Huh?
It's a bit radical.
Yeah, I mean, I was trying to teach them the harshness of life, really, but it's a bit hard when you're like 4 years old and somebody's trying to teach you the harshness of life.
Well, yeah, telling them about AGMs.
Well, I mean,
Not a good one.
I mean, your parents, you know, do that. They teach you about the harshness of life. When I was younger, there weren't any paedophiles around. They didn't exist. Actually, there were loads around. We only found out much later on. Whereas your parents tell you, you know, you've got to be careful. You can't go off with strangers and stuff like that. So they, you know,
but it's still harder for 4-year-olds to understand death.
Death. Okay.
So I don't think you should really do that.
Okay. So we're going to square both of these. So it's going to become log to the base 4 of t squared plus the 2 equals log to the base 4 of p. And then we're going to put these log terms together. Log to the base 4 of p over t squared equals 2. And then we're going to do 4 to the power of both sides. So p over t squared equals 4 to the power of 2 is 16. P equals 16t squared is our equation. Okay. And you do this one for me, Banchita.
So you take minus 3 log to the base 3x to the other side.
Okay, done that.
Then you would Oh, then you put the 3 as x cubed. X cubed.
Lovely. Done that.
Then you do log 3 and then y times x cubed.
Done that.
Then it will be, then you get rid of the log 3, which will be 3.
Lovely.
And then, yeah.
Splendid. Fantastic. Okay. All right. This one here's a little bit more tricky because, again, I've kind of messed it up a bit with having logs of different bases. But you know how to fix that, don't you? Because do you remember I keep telling you this story? I keep telling you about my calculator. It doesn't have a log blank button, which yours has. Yours has this lovely log blank button. Mine just has log and ln. Those are my only two choices. So if I want to type in log to the base 2 of 7, I have to type in ln 7 divided by ln 2. That's how I type it in. Okay, go back to this equation. How are we going to rewrite this without the logs in there? I'm asking that to Saba.
Okay, so would you take the 3 up, so it's x cubed first?
Okay.
And then would it be ln x cubed over ln 3?
Ln 3, yeah. Yeah.
And then would you bring it over to one side? Or...
Yeah, okay, so ln y plus ln x cubed over ln 3 minus 2 ln 7 equals 0.
Would you then squash the logs?
You can't squash the logs because for you to be able to squash the logs, this log can't have anything in front of it. And this log can't have anything in front of it. And this log can't have anything in front of it. And 2 of our logs have got something in front of it. This one has got a minus 2 in front of it. I mean, the minus is all right. You're allowed a minus, but not the 2. And then this log has got a 1 over ln 3 in front of it.
So would you multiply everything by ln 3?
I don't. That's not gonna be nice. That's gonna make it even worse. You know, ln 3 is just a number. Look, I'll type it into my calculator. Ln 3 into my calculator. It's just like 1.1. We'll call it 1.1 as if it is actually 1.1. It's not really, but 1.1. Ln y plus 1 over 1.1 ln x cubed minus 2 ln 7 equals 0. Does that help at all? I just changed the ln 3 into a 1.1.
So would you bring it to the power?
Yeah, I mean, I might as well recip it now, so I know what that is. Recip, so to the power minus 1 is 0.91. Is 0.91, and then I've got to times it by the 3. As you said, I've got to bring that up. So if I'm going to bring that up there, I'm going to have to times it by that 3. So times 3, 2.73. It's still a bit rough. But ln y plus ln x to the 2.73 minus. Do you want to do anything with this one? Saba?
I can't see the...
Oh, okay.
So is it ln 49?
Ln 49 equals 0. And now you can squash it into one log. Whoops, ln, not log. Carry on.
So is it ln yx to the power of 2.73 over 49?
Now you can get rid of the log.
So do e to the power of, so it's equal to 1.
X to the 2.73 over 49 equals 1.
And then multiply by 49.
Equals 49.
And then divide by x to the...
X minus 2.73. Okay, lovely. Okay, so what we've got is we've got some data, and we plotted the data, and we can't really tell, but it looks as though a nice curve should fit that data. But fitting curves is notoriously tricky because there's so many of them. So what we want to try and do is we want to try and change this data, find a way of replotting the data so that when we plot it, the graph does not come out curved, it comes out as a straight line. And so I just guessed, I said, well, why don't we just try logging these values? Just as a guess. It was a pure guess, pure random guess. Why don't we just try logging these values? And I might do that. If that doesn't work, I might try logging the x values. And if that doesn't work, I might try logging both of the values. And if that doesn't work, I'll probably give up. I'll probably be stuck. So, okay, so I logged all the y values. And then when I plotted those points, wow, look at that. Now, the thing about straight lines is you can easily test if these do lie along a straight line. Well, they very well do. They extremely well do. In fact, they lie so well along the line that it's even better than I can draw the line that they lie along the line. Okay, so that came out really nice. Okay, and that means I could now pick up my calculator and I could type in that data. So I'm going to go to menu. I'm going to go down one, across one to the thing that looks like a bar chart, stats. So down one, across one to statistics. And then I'm going to type in y equals a plus bx, number 2, y equals a plus bx, number 2. When I do that, I should get x's and y's and no frequencies. If you've got frequencies, you might need to turn them off. You press shift and setup, shift and setup, shift and menu, which is setup. Then you go down to statistics.
So how do you do it on this calculator? Oh God.
It's a shame you're going to have to tell him how to do it on that calculator.
Just gets, oh my.
So we're going to press 3 to go to statistics, and then we're going to turn our frequencies off. So number 2 is turning our frequencies off. So we don't have any frequencies. And then I'm going to type in, Shane, can you explain to Shalom how to put in the table into there? I presume you have to go into the table mode, stick in the table, and then
I think
statistics.
you go to menu, and then number 2, statistics. And then there's a button called set. One variable frequency.
Where's set?
F6.
6?
F6.
F6?
Yeah.
It just comes as a arrow.
Which mode are you in?
Stats. Number 2.
Number 2, then.
Yep. Because
Click calc, F2.
Oh, F2. Oh yeah, set.
And then set. Then one variable frequency.
Yeah.
And then click 1.
Yeah.
And then that's it.
Okay.
Okay, so we've typed in I've typed in all my x's along here, and then I've typed in all my y's into the calculator here, and that's all stored in the table now. So you can see that table. Now I'm going to press the AC button. So now I'm going to press the AC button. That will make the table disappear, but I'll see the statistics. I'll see that I'm on statistics mode, and I'm going to press option, and I'm going to ask it for the regression calculation, number 3, the regression calculation. And it tells me my line of best fit is y equals 5.528 minus 0.695, I'm going to call it, x. So that's my regression line that it tells me. You should have got that same regression line. And what you see at the end of that is a correlation coefficient R of minus 0.99999, which is fantastic, almost perfect negative correlation. Numbers that are close to -1 or close to 1 means that your correlation is fantastic. If you've got 0.5 or 0.6...
Oh wait, how do we do it on the calculator?
Shane?
I haven't actually worked it out yet.
So when you finish pressing your data, you have to go probably into option, and then you have to go to 2 variable, and then you have to go to regression. Once you finish typing in those 2 columns of data, you then press.
What's the value for the regression?
Sorry?
What's the value for the regression?
It should.
Oh, Shalom, I got it. You just have to do you just have to press calc and then reg next to 2 variable, and then it shows you just press median or whatever it is, and then it gives you the thing in y equals ax.
Oh, okay.
Mine says no data.
It's lost the data. Maybe the columns it's looking in are different for your data. Go to your setup, get your columns across.
Wait, median is getting a different value. What?
I got that.
Yeah, that's what I've got, which is different to the.
That's what Sarah got.
It's if you look at it says got negative 0.695, and we're getting negative 0.692.
Oh.
Go back to yours and go back to regression. Yours might have 2 different types of regression. It might have a y on x regression and an x on y regression. You need to do the y on x regression line.
Okay, if we do that, then.
So this is a silly question, but how do you input the values? Like, what do you use as your x, y for like?
These x is going to be 2, 4, 6, 8, 10.
So I've got it here. Like that. Do I put the x's?
No. It's got to go down. They've got to go down.
Oh, okay. How do I reset?
Shalom, whoever's talking in the background, can you ask them to be quiet?
I'll mute myself.
Is that better? Is that closer?
Yeah, 0.69476. Yeah, that's what I got. Well, okay, yours is still slightly different.
What did you type on there, Sean?
Over here, I just press instead of doing.
Yeah, so it's cross. It's cross, and then a plus bx.
Oh, a plus
bx.
Yeah. Okay. So a plus bx is that.
Yeah, 5.528 and minus 0.694. Yeah, there's a slight difference between your B. I'm not sure why. That might just be a typo in.
So are you rounding your? You rounding the
I've
values?
rounded my numbers. Yeah.
Oh, so then that might be it, because we've entered it as exactly 62 minus 62.
Okay, so we've got our regression line, but remember the y-axis wasn't y. The y-axis wasn't y. It was ln-y. So what I do to denote that is I rub this out. I don't call it y, I call it capital Y. Capital Y means Y that's been transformed, Y that's been changed. I call it capital Y like that. And if I've changed the X, I'd also call that capital X. Now what I need to do is substitute back. That was actually ln-y. So ln-y equals 5.528 minus 0.695x. And then now I'm going to do e to the power of both sides. So y equals e to the 5.528 minus 0.695x. And then I'm going to do y equals e to the 5.528 times e to the minus 0.695x. This I'm going to type into the calculator, e to the 5.528, menu 1, e to the power 5.528 gives me 252. Y equals 252 e to the minus 0.695x, which is an exponential decay. That is an exponential decay equation. If I want, I could rewrite it. I could rewrite it as y equals 252 e to the minus 0.695 to the power x. I just push the x slightly higher out of the way. And then this, decimal that on the calculator, e to the power minus 0.695 gives me, well, roughly 0.5. Y equals 252 times a half to the x would be my equation. So what I've successfully managed to do is to find the equation for that line. And I found it, find the equation for this curve. find the equation for this curve. And I found it by reducing it to a line. I have to take my curve, reduce it to a line. Once I got a line, I find the equation for that line, and then I unreduce it. I go back to what it was before. Okay. Okay, so there's our equation. Okay. When so this one, somebody's already done it for you. They've already produced the line, and you can see those points lie really close to that line, so you can see there's good correlation in that data there. I mean, sometimes you get good correlation, but it doesn't imply that they do fall along the line. So for instance, if you get data that looks like this, that will probably give you a correlation coefficient of 0.94, 0.95, but I think you and I can see that a curve is better fitted to that data than a line. A curve is better fitted to that data than a line. And the reason being, you've got points at this end all underneath the line. You've got points at this end all over the line. And you've got points in the middle touching the line. And you tend to find that a lot. You get something like this, and you get points like this. And you can see that a curve would be better in that case. If the points on one side are below the line, the points on the other side are below the line, but the points in the middle are above the line, then maybe it's not a line in the first place. Okay. But this does look like a line. This does look like a very nice line. So if this looks like a line, let's find the equation of the line. The equation of the line is y equals, the y-intercept is 2, and the gradient is -2 up, 5 across, -2 over 5x. But hold on, that y-axis is not y. So let's get rid of that and put capital Y instead. And that x-axis is not x. So let's get rid of that and put capital X instead. So it forms a line, but only when you transform the x and y values. Now, if I undo that by replacing them back again, so y actually stood for log to the base 10 of y, and x actually stood for log to the base 10 of x, then that gives me equals 2 minus 2 over 5 log to the base 10 of x. Now I'm going to collect the log terms to one side, so log y plus log x to the 2 over 5 equals 2, and then now I'm going to squash them into a single log, log y x to the 2 over 5 equals 2, and now I'm going to do 10 to the power both sides. Y x to the power 2 over 5 equals 10 to the power 2 is 100. Y equals 100 over x to the power 2 over 5. Okay, so they gave me a straight line. They managed to get the straight line by using some modifications to linearize the data. Once I've got the straight line, I can undo those modifications and go back from the linearized data to the actual equation. Okay, Lily is given a radioactive tracer to treat her cancer. The amount of radioactivity she is emitting T hours after its administered was recorded. Determine an equation connecting C and T. Now this question, we have to ask ourselves, have they already told us the equation? Have they already told us the equation and they just want us to find the constants? Or have they told us no equation whatsoever and we've got to start from scratch? And in this equation, in this question, they haven't told us the equation, but I do recognize this situation. This is a radioactive particle giving off its radioactivity. That's a standard exponential decay equation. That's just exponential decay. And for exponential decay, I expect C to equal C naught e to the minus kt. And because of that, it means I know the format of the equation. I know what form this equation is going to take. And because I know what form the equation is going to take, it's easy for me to figure out what will linearize it. Otherwise, I'm guessing what's going to linearize it. Whereas here, I don't need to guess. I'm going to take ln of this equation. So that's going to give me ln C equals ln C naught minus kt. Now what I'm going to do is I'm going to box this. I'm going to box this, and I'm going to box that. And the reason I'm boxing that is because this is now going to be renamed as y. And this is now going to be renamed as x. And so what I should get is y equals c plus mx. Y equals mx plus c. Y equals mx plus c. The rule is whatever you decide is y can only have variables in it. C is a variable. Whatever you decide is x can only have variables in it. Now there's a lot of flexibility in there. Yeah, this is only allowed to have variables in it. Mine's only got t in it. But if it had t squared in it, that would be allowed because that's only got variables in it. If it had 1 over t, that would be allowed because that's only got variables in it. If it had c over t, that would be allowed. Salam, Salam, mute yourself, please.
Oh, sorry.
If it's only got if it's got 1 over t in there, that's only got variables. If it's got c over t, that's only got variables. So this could be c over t in there, it'd be okay. It could be t squared times c plus 1 divided by t. That'll be, as long as it hasn't got any of these constants in there. These are the unknown constants that I want to figure out. This unknown constant and this unknown constant, the k, are the ones that I want to figure out. And they must be outside of the brackets. So outside of the brackets, you can only have constants. And inside of the brackets, you can only have variables. That's the rule. Yeah? Inside of the brackets must be. Okay, so what I've realized is the correct way to do this is to log these values. Is to learn these values. Learn C, learn that, learn that, learn that, learn that, and learn that. And that should linearize it. That should linearize the data. Okay, well, I haven't done it. Let's do it on the calculator. So I'm going to go back into my stats mode. I'm going to type in y equals a plus bx, which is number 2. I'm going to type in 2, 19, 31, 38, 42. I'm going to go down and across. So I'm at the top of the second column. I'm going to type in ln 518, ln 311. I can't read that number now. Ln 311, ln 217, ln 176, and ln 156. Okay, that's all my data entered. Now I'm going to press AC, then I'm going to go to option, then I'm going to press regression calculation, which is number 3. Look at that correlation coefficient. Isn't it lovely? That's the test. If that is very close to 1 or minus 1, then we've got great linearization of that data. So it gives me y equals 6.31 minus 0.03 x. Hold on, using capital Y and capital X. Using capital Y and capital X. Capital Y and capital X. But hold on, capital Y stood for ln C. And capital X stood for T. And then I'll do e to the power of both sides. That gives me C equals e to the 6.31 minus 0.03 t. And then that gives me C equals e to the 6.31 is e to the 6.31 is 550. 550 e to the minus 0.03 t. There's my model for that data. If I then go into this equation, I type in 31 or 19 or 38, the numbers will come out like these numbers, come out very close to those numbers. So this equation, they've given us the form. When they've given us the form of the equation, we use that. They're giving us that, that's helping us. And we need to linearize this form. So the rule is, we want to get it in the form of y equals mx plus c. Y is going to be boxed off, x is going to be boxed off, only containing variables in there, and only containing the unknown constants out here. Of course, a number like 1, which is a known number, can be anywhere. That doesn't make any difference. So I'm going to log this. That's going to be ln m equals ln m naught plus n ln t minus 1. And it's already immediately ready for boxing. There's going to be my y, and there's going to be my x, and then this is going to be my m, and that's going to be my plus c. Okay, so what I'm going to do is I'm going to learn all these m values. That's what I'm going to do. I'm going to learn them all. Now with the t values, I'm going to do something even more involved. I'm going to first of all minus 1 off of them, and then I'm going to learn them. So I'm going to knock 1 off of all of them, and then I'm going to learn them. And when I've done that, and I've put it in the calculator, I'll get a straight line, and then the gradient of the straight line will tell me what ln of m naught is. So I just do e to the power of the, so the y-intercept of the straight line will tell me ln of m naught. So I just do e to the power of whatever the y-intercept is, that will give me c. And the gradient will just immediately tell me what n is. The gradient will tell me what n is. So just type it in, gradient immediately tells you what n is, and e to the power of whatever the y-intercept is will tell you m naught. Then you've got your equation, then you can check it works. Again, they've given us the equation. This equation is to do with a situation. It's to do with a hot liquid being placed in an insulated flask in a room which has a stable temperature of 20 degrees. That's Newton's law of cooling. So we probably know some other stuff to do with that, which will help us with a question like that. Here again, they've given us the form of the equation. So they've given us the form of the equation, and so if we want to linearize this, we need to find a way of rewriting it.
Sorry, sir. My internet had a I want to reset moment.
Okay. So we got P equals A e to the 3t over B plus e to the 3t. Now, I love splitting the numerator, but I know I can't split the numerator here. But if I reciprocate it, I could. 1 over P equals B plus e to the 3t over A e to the 3t. And then I could split this fraction. 1 over P equals, so that's going to give me B over A e to the minus 3t plus 1 over A. Now it's already ready to be boxed. That's going to be capital Y, that's going to be capital X. Why? Because that only contains the variables, which is P and T, but it's only got P in it. That only contains the variables, which are P and T, that's only got T in it. This only contains the constants. This only contains the constants. And this only contains the constants. So, M plus C. So what I'll do is I'll get my table. I'll recip all these values. I'll recip all the values. I will do e to the power of minus 3 times t value. So I will do e to the minus 3 times that, e to the minus 3 times that, e to minus 3 times that, e to minus 3 times that, e to minus 3 times that. And then when I ask the calculator, I'll get a straight line. And the straight line, its y-intercept, if I recip it, that will tell me what A is. So I'll know what A is. And the gradient of my straight line will be B over A, but because I already know what A is, I can just do the gradient times A, and then that will give me what B is. And so I'll know my equation. So that's how you convert it to linear law and find the equation of the line. Okay.